As you all know, my name is Joshua Francis, the COO of Vites Energy, and I'm here to present about solar installation safety and risk mitigation. So now, based on this, now we have today's agenda, which is going to be about introduction, the safety first mindset, and the second, personal protective equipment, PPE. The third is work at height, fall protection. Four is electrical safety, the DC danger. The five is lockouts, load to procedures. Thank you. Battery, energy storage safety, environmental, site hazards, and then conclusions. That is just what I'm going to talk about. I believe with looking at it, I think it's very easy to understand, even though you haven't explained it. So it's going to be, I'm going to be communicating. Asking a question, you'll be asking me a question. At least we have the internet right here. You can also search if possible. So the next time we're going quickly is to the introduction and the safety first mindset. So safety is not a checkbox. It is a personal discipline. In solar engineering, a single mindset can be fatal due to the unique combination of height, high voltage DC, and the environmental factor. Now, what do we need to note here? Every engineer is responsible for their own safety and the safety of their teammates. Our word today is zero harm. Now, the introduction of the mindset of safety means that each and every one of us, we are brothers. Each and every one of us, we are not segregating anybody. That is the main importance of safety here. Meaning, nobody should have harm. Maybe you see your brother, okay, the bag, I want to talk about that. Maybe the bag or one thing, or the shoe or one thing, or the hand is not well insulated. You quickly bring attention to the person. So the person will quickly do that before going up or before doing anything. That's what we're talking about here. Now, talking about the PPE, remember I talked about the agenda of today. I said we have the introduction, and then the second one is the personal protective equipment, which is the PPE. Now, looking at the PPE means what can you see there?
Personal protective equipment.
Exactly, the personal protective equipment. And you can see that try to make sure I put it in a way that we easily understand it. Now, the personal protective equipment, which is the PPE, is personal protective equipment for a solar engineer refers to specialized safety gear worn to protect against workplace during solar installation and maintenance and inspection tasks. That is what you wear for proper safety. They are very, very important. You can see what the helmet, you can see the what wear safety helmet, wear the eye goggle protection, wear eye plugs, ear plugs, that is for dust. Wear your dust masks for the nose, when necessary, and then many others. You can see them, they can easily read them as you see them, right? Yes. Very good. Now, it includes items such as helmets, insulated gloves, safety boots, goggles, and harness. The harness is the full kit you are seeing here. That is what we call the harness, which helps prevent injuries from electric shocks, falls, burns, and environmental exposure while working on solar systems. So these are the necessary PPE for working as a solar engineer. I know most times we want to work, but most times we may not have all kitted. But you should, if you are thinking and you are looking, if I'm not even on this, I should always be careful of this. Now, if you look here, we know that the harness now, this harness now is for all this stuff now. They call it the wire harness, understand? For you to hold yourself in the roof. Yeah. Because even last time when we do the last installation, me and my bro was like, let's use this because if you don't use it, you can fall. The roof was like this. And you know, the way Lagos is, they are competing in in who has the tallest roof, which is very delicate, the way the engineers. So the next thing I'll be quickly going, but I hope you understand what the PPE is. Any question, you don't ask any question, but just look through it. You have the shoe, you have everything. Any question? Before we move to the next slide.
No question.
Okay, now no question, let's move. Now the next slide is we are having here is the The personal protective equipment, which we already talked about, still the same PPE. You can see under the PPE introduction. So now we have the head protection, which is the non-conductive head hat. We have the head protection insulated gloves rated for the specific DC voltage for the arrays, whereby that is for this itself very very necessary in anything we are doing. Very well necessary. Now we have the footwear EH rated. When we say EH, we mean electrical hazard. Boots with non-slip, boots that have enough frictions. You know when you have enough frictions on boots, not the one that can be slippery when you're on the roof. We also have the eye protection. That is the UV rated safety glass. It helps to protect the eyes when maybe from sunlight or from the reflection of the solar panels. Now we also look at the notes. So wearing PPE is the bare minimum. Ensure all gel is for tears or degradation before every suit. That means what we're trying to talk about here is that the PPE is just the bare minimum. You can still wear all these things and still have hazard or anything. So we're still going to go deep on that. Now the next slide is walking at heights and fall protection. Oh, what you can see is self-explanatory, right? I try to make sure we all understand it by just looking at it. You can see here someone trying to hold it, NS. You can see here someone trying to fall from a ladder. You can see here now we have the proper use of NS and layards, pair off points. Now what does it mean when we talk about the proper use of NS and layard? Now we know that the NS and layard is what we use to climb the roof. Yes, where we are working on the normal ground, we don't need the NS on him because most time heavy. It's not used to climb on the roof now and the layard now. But now when you are now going up and you now sometimes people like, let me remove this anchor now and hold it. Maybe I want to go a certain point. Doing so, maybe your teammate should be at watch to watch you to make sure you get to where you are before you clip it back. Because if there's any mistake and any fall happens, it can be very very worse. Very very bad. Now look at the next one, which is the ladder safety. The 4-to-1 rule: for every 4 feet of height, the base should be 1 foot out. I'm going to talk about that now. Okay, based on that, I'm going to be explaining what it means here because I just put a point here. Now, when we have a ladder now, let's say we have a ladder. Just use this please. Let's say we have a ladder. When we talk about ladder, we talk about it under 90 degrees. What does that mean? A right angle, we are all engineers, right? You know what a right angle triangle is? That is, or we are going to go deep on that. But when we talk about ladder, we talk about this now. Let me just draw it like this. So this is how a ladder should be. So now we have the 4-to-1 ladder rule. It is a simple way to position a ladder so it doesn't fall backward or slip. Now, I'm going to just explain it easily for us to understand. For every feet height, the ladder goes up the wall. The base should be 1 foot away. Now, once we say what do you mean by 1 foot away? Now, 4 feet high, base is 1 foot away. Let me just summarize everything here. No need of talking much. Now, thereby you are on a ladder. Let's say before you climb the ladder, to know it's well structured for the person going up not to have injury. The assistant here should place his hand and place his leg. Now this alone calculates everything, but between here and the leg, the distance between the leg and here and the hand explains it all. Is what you need. Once your leg distance and your hand, you hold it like this. Once it's like this, you already know that you are already in a good position. I'm trying to explain what they are trying to talk about: the feet, the bottom feet and the height feet. Now, they are trying to say that in every height it goes. In every height it goes to come back. Come back, like, let me explain. Let's say if this ladder is like this, because the roof ends here now. Now let's say the roof is longer now. Let's say something like this now. Something like this now. I cannot put the ladder like this. I can't put the ladder like this. Why? Because at this point, the ladder is not on anything. And here now, in If you have what we call force, if the person is climbing and the person is at this point, there's nothing holding it and can easily fall. So now, when we're not saying every how far it goes, you shift it by 1 foot, then you have to put it closer, like this. That's just what it means. Hope you understand.
Yeah.
You understand. So if it's closer, then if it's closer and the person that is holding it has already put leg to measure it and say yes, it's accurate with my hand and leg, then the person can go up. Then when the person go up, there won't be any hard. Not like this now. Except that there is something holding here, but there's not something like that. Even the aluminium is exactly. Even last time we had installation, the aluminium ladder almost broke at the middle because of this. So it's very, very important that we understand it. Oh, do you understand?
Yes.
I'm sorry. I understand what you're saying, but
at the point of it going back, I mean,
to me, sometimes if I position the line like this, when I get to the stage, I feel like
The weight is going back.
exactly.
okay, yeah, it's usually like that most times. Whereby that's why there's have to be extra person at the bottom. Yes, that's why somebody must be here. That's why somebody must be here. Yes, to be holding it,
Yes.
hold it firm. And that's why somebody must be here to hold it firm. That is also the rules about the ladder. So there will not be anything like four, because only one person going up. That's why everybody is working as a team. Or we're working as a team. Any person going up, follow the person up. Most times, if somebody goes up, he goes the ladder up and down. So all this is was necessary. Then we go to the next one. Hope you understand the ladder now.
Yes.
And this. So we go to the next one, which is securing tools to prevent dropped objects, hazard to those below. Now, what does it mean? Whereby we have tools, whereby we have now we always have this waist bag that we carry up there, and we also have tools bag too. Now, it is very necessary that you secure it properly. Most times, you may not be carrying your tools box up there because of how heavy the tools box may be, but you will be carrying a bag, and that bag now, it does not have leakage. That's what we're trying to talk about. Because if it has leakage and it falls, it's not only about it falling, but hitting people below. And so to make sure everything is professional and secure, you should have your waist bag, and you have the bag you are using to carry where it's plated should be strong enough. And it's very important too, because when the sun starts, when the sun is very, very, very hot, because now I think based on experience, when the sun is very, very hot, the bag itself can start melting. Yes, the bag more times get start melting, because last time we went for an installation, the bag almost started melting. Even our trousers was almost melting because of the roof was aluminium and the sun was very intense. So it's very important that bag you are using, we use the poly bag to go up. The bag you use to go up, just like nylon bag, you can see that it will melt. And so like a poly bag, a double poly bag can help with that, and also a waist bag too. Hope you understand that. Hope you understand this. Thank you. Let's go to the next slide.
Okay. I want to add something on that hand gloves.
Okay, yes.
You see, it doesn't mean that we have different gauge, different DC, different sizes of.
Yeah, of installation we have different. It's not all of them that can hold electricity. Not all of them.
Okay.
You have the ones. They have the silicone. The silicone cannot hold it for like it can't hold. How will I put it? You only wear it for, I think I saw it, there's one people were wearing during the last installation. The red cloth, they call it cloth handle. Not just the cloth handle, you can see that the part,
There's a rubber.
and there's a rubber here. That one is silicone, and silicone has, according to the study, silicone has, I think, about 45% conductive with electricity. It's very, very conductive. So I'm speaking now by experience. Let me explain. I was in my ND1. And I thought that it was an hand glove. Serious, I was very, very sure. I thought I bought an hand glove, and I went to school with it. And I was trying to repair, I was trying to do wiring for somebody, and I was using it, and it was light. And I know I want about electricity that you should at least switch off all the necessary before you start working. But I was working like I was with hand glove. I was like, nothing is happening. Now, as I was working, before I was trying to do one or two tights, the thing was my nails empty scatter. I was like, I was not thinking why did such a thing happen, injury, blood everywhere. I was on the hand glove now, and I noticed that hand glove is not insulated because it has the silicone inside, has a conductivity with electricity. So that's why we do not compare rubber and silicone are almost the same.
Okay.
Yes, so the one we are talking about for your more protective hand is rubber. That one is very red.
Yeah.
You can now one is different, but most times we don't.
NEPA uses.
Yeah, it says, but now if you look at it, inside it is being coated with cloth, with threads. If you look at inside that, it's coated with threads, not like the normal one use. Inside is like foam. So that one you wear for the clothes on is just based on work. Just mainly work, you are down, you are trying to do little wiring, putting on the light. But that main is for when you are on work, you want to start doing the changing over, you want to start doing the testing. Even in the up, when you are up, you are trying to do the connection of the panels. It's very, very important to wear it. I'm not lying to you. It was very serious. I read that point later because something happened last time. Okay, now we talk about this is danger. Now, firstly, we talk about understanding the PV models are always on when exposed to light. Now, let me explain this first. As simple as you read it, it may look that simple, but very serious. Because look at understanding the PV models are always on when exposed to light. Meaning, if this panel sees sun, is already on, meaning there's already charges in it. You need to be careful when using. Now, last time we were on installation, we forget this part of we forgot this part of stuff. We're doing the connection and we're okay with it. Before it was just only three panels that was connected, and each panel was around, remind me, around 51 volts each panel. So it was only just three that was connected. And if you see the shock, we'll experience the shock of our life. Because one panel, this height was, let's say this is the three panels now. This is the three panels now. See, one was on the roof. Then we were trying to be with one on our hand. Understand? So we're like, let's go and get this other one. Where is the other one? We're looking for the other one. Before we know, this one on our hand touched the roof. The roof shocked. The roof started shocking. And imagine the volts that was coming out of that stuff. We just thank God that we were on a well insulated boot. We were able to pick this one up and down. I was telling my brother, imagine that within all the panels we connected that day, I think connected about nine panels. Imagine we connected, just imagine we connected 9 panels and we were, let's say this is the roof now, we connected 9 panels. And we have not done finish the connection, so the wires and the roof say we come the next day and continue. That's why I'm trying to talk about based on experience and fact. Now imagine we now come and climb now and we touch the roof. Now you just see how somebody will not jump out of ladder. Why did you jump out of ladder? What is wrong with you? You don't know that the roof is shocking. So it's very, very important. It's very, very important to understand the PV models are always on when exposed to what? To light. So the next one is using properly insulated tools and multimeters rated for the system voltage C83 or C84. So now we have let me just explain the grading. But why you are seeing C83 and C84? Hope you understand me. Now C81 simply means small electronics. You understand? Small electronics, gadgets. We have like our phone. You understand? We have like our phone. All these things they call them they are grouped under C81. They don't have their voltage is between 15 to 5 volts. You understand me? Now we have the C82, which is the house appliances, the fan, the TV, the mortgage rigs. Don't worry, when you see you talk about that one, you will talk about more about the C80, like the description. Now we also want to have the C83. Now this is very important to understand. Distribution level with buildings, panels and wiring. That is, this one is what this kind of voltage is grouped under panels, building and wiring. That is, if you open a particular wire and you hold it, see, why am I shocking? Why is it shocking? And why is this? Why will I open this gadget now and it not shock me? Because the voltage now one is more higher. Now you have, for example, distribution boards, circuit breakers, industrial wiring. They are of a very high voltage. Now what we call the C84. That, for example, source of power, where electric enters. That is the main place where electric enters, which, for example, electricity meters, transformer, outdoor lines, which is what the transmission lines we have outside there. Those ones are what C84. Never mind. Very, very important, because if you touch that one, you're gone. There will not be anybody to explain matters to you. So now we hope you understand what the CAT is all about. Now we talk about, now we are saying that using properly insulated tools and multimeters rated for the system voltage. That means if you use a wrong multimeter gauge for a CT for CAT4, it's going to damage and you're going to get injured. Let's say we have to set a multimeter now to a voltage of a voltage of, let's say we are operating on a voltage of a current voltage is around 400, let us say 400, and our multimeter gauge stopped at 2, we put it at 250, and we test this is going to damage the multimeter will blow, and at the point of blowing it can also damage the tester. So we're trying to say that when you are trying to work in a industrial settings, or in this, we are working as a solar engineer, we should understand that when setting even a multimeter, we should set it above, we set it around 600. We set around 600 volts to understand the accurate capacity, to understand the flow.
Yeah.
Because any mistake can damage you and the system itself and everything you are using. Yes, it's good though, but you know, most times, if not because of the rectifier that helps to convert the DC to AC, we won't be talking about this. Because now once we are getting directly from the panel is direct current, right? Now, but now it's entering the system and the rectifier is converting it now to AC. Now it's of dealing with AC now.
Yeah.
But if you look at it now, we're talking about DC danger. DC danger, what you have in this now. But if you put it directly on 400 volts, how will you know it's 400 volts when you contested it? That is the question here. How will you know it's 400? We don't know. So if you are doing anything concerning industrial panel and all that, just know that let's put it at 600, at what 600 when doing the settings. So I believe you understand this, right?
Yes, but if I may ask you,
Okay.
you mean that can you set it to 400, but the voltage you are testing is maybe between 100?
Yes. If you are talking about if you're talking about lesser voltage, like let's say the CT2, know that those are gadgets. Things like gadgets, and let's say I want to test adapter, and I don't need to be setting this thing now at 400 because now it will give me a rating below, it will give me things like point.
Yes.
Now, so I have to now come down to level of this. I'm be setting it around, let's say around 200 to be seeing something like but imagine I'm just trying to explain the difference. Yes, if you climb high tension now, there are people that detect the high tension wire, and they use a different multimeter and they actually putting the rating around a higher one than you get. Now, I think everybody's engineers, and we have the Nigerian rating, the US rating of electricity and all that. You can do more research on that. But hope you understand this, right?
Yes.
Hope you understand this. So now let's look at the next one. We have the ARC flash hazard and high voltage DC direct risk. Now the flash hazard and high voltage DC is direct risk, like direct current. It's whereby you can build on it already. It's whereby you have voltage is high and you're not aware of it. Then you get in contact with it without knowing. Because normally we touch DC, it's not harm you. Normally we touch DC battery even with our hands, it's not harm you. Whereby the voltage is very, very high and you do that kind of contact, it's between you and the creator. Now we go to the next one. I think we already done. Take a little note on that. Say, unlike AC, DC current can cause continuous muscle contraction, making it harder to let go of a live wire. With every model as live. What does it mean? Now, if you look at it now, if you are handling things like the AC, it is very, very different. AC is very friendly, let me put it this way. You can touch AC now. You start before you even touch it, that push you out. But if you are dealing with this, it's dealing with you. If you both of you so now draining you, killing you. That's the guy is saying it's better to treat every part as life. Though we know that when we are talking about life, we may talk about alternative current. Alternative current now have red and black. Is when we are talking about this, we have red and black. Hope we know that by now.
Yes.
we are engineers. Now, because we alternate current, alternate between, but this is just direct. Now, I'm trying to say, if it's in high footage, better just treat everything as live. Don't make a mistake. Hope you understand. Try not to make mistake when dealing with wires like this. Now, let's go to the next slide. Next slide, we have the lockout targets. That is the load. I think when I was saying that time, you were like, what am I talking about? So the LO means lockout, then the TO means tag out. Now, procedures. Now, identifying all energy source. That means we're trying to say, what is our lockout target? We're trying to say, it means what is our look at target? What should we look at? What should we be conscious about? Now, on what should we tag out? What should we say, okay, this is important for us to know before doing something like this. Now, I was trying to say, first thing, identify all energy source, which is what the PV arrays. When I say PV means the solar panels, right? PV arrays, battery storage, and utility guide. The next thing, mandatory use of locks and tags during maintenance. Very important. We all know that by now. When you are dealing with wire, I think last time people were doing solution, people were tagging it now. People were, what I mean by tag, like, no, but I mean that those tapes people are using to identify each. Yes, so to know the one that's going to this room, the one that's going to that room, the one that is coming to the junction box, the one that those tags, those cable tags are very, very important. That what we mean by tag out. Mandatory use of locks and tags. Now, when you don't know what the locks means, that is that stuff we use to lock stuff. Very important, and the tags. So now we know what the tags is now to identify. Now, the next one is mitigation of zero energy state before starting work. Now, it's very important to know that let's put this system without anything on. Let me explain. When you are trying to on a system, let me sit down to talk based on experience now. The last time we did an installation at Imo State, we make sure everything down is off. That is, they have the inverters, the sure everything is well off. Then we now say, well, let's connect. When we did the connection, we now say, well, let's check. We're checking out with multimeter. Checking with multimeter. We didn't give the whole system direct light because we don't know anything can happen. So you need to be careful. So it's part of safety. And so it's part of safety measure. So verification of zero energy state is very, very, very important. So people understand that. Now, note, Lotto saves life. Very important, it saves life. Never assume a direct current is dead just because a switch is off. Test it, lock it, and keep going to it. You understand now? That means always don't say, okay, because I've off this, it's off. And let's not be assuming. Let's always keep things factual. Let's not assume. Let's put things as it is. So if you are offering, if you are doing that, like if you are connecting wires, you don't just say, okay, your head say, yes, I know I've put this other wires, like this other ones are entering that room. No, tag it. And not just that, when you are treating on it, you don't say, okay, I've offed. Use it. Like, you ask the other engineer, hope we off that other side. I mean, say, I think we did that. And you just think, you just go and check it. Don't need to think. It's part of hazard. Don't think, check it, let it be fact. You can also snap it picture. It's very important. When you snap it picture and say, yes, I'm off it. You go up, you check it again. It's what's important. The next one.
Thank you for this thing that you just said now. Very, as in thanks, because this thing has happened to me in some way.
Okay.
I don't know that the electrician that worked here before, because the circuit breaker has gone. He went there and did what? Bypasses. Thank God for this digital meter. I still make use of my meter and leave it. I found out that after opening it, there's still light there. That was when I found out that they already bypassed it.
Blood for man lost day.
I forget that now.
So it's very important to do what? To check, factual checking of your systems. Now the next thing is what? Battery and energy storage safety. Now that means if you look at it, looking at the heading, the battery and storage and energy storage safety, that means checking the battery if it's well, if it's really in a good state before you start using. Now let's look at what it says. Handling heavy batteries like the and lifting tech. Now that is when you are dealing with the batteries like lithium batteries, let me put in a way you understand. They are very heavy. So you need to understand that lifting it is usually sometimes they use some things to lift it or more people to lift together. Last time when we were lifting, now I just use our hands to lift it because we're not that heavy. But when we went to a distribution company, one of our partners, KTech, we saw them when they were loading and everything. You can see that they were using machines to load and everything. They were not using their hands or anything because it's very, very hot. If one battery falls down, it's a bigger risk to load it on or to put it on because terminals could have broken inside and can lead to explosion. Now, terminals runway rigs and proper ventilation, you know that one by now, whereby where you're putting that battery, talking about the safety of the battery now, where you're putting that battery now should be a ventilated place. As an engineer, when you're trying to arrange a battery or we go and meet a customer and the customer say yes, I want to install, where can I put this battery? You're not looking at the conjunction box now, you're looking at under it now. You're looking at a place that was fitted for the battery. Because you can say, okay, the conjunction box of the house might be inside a particular room where there's no ventilation, no window, nothing. Now, and putting a battery there can be very, very bad for batteries like the tubular batteries, especially the tubular batteries. But the lithium can serve, but it is not good. It's not good for the batteries to be in good health. They need good ventilation. That's why even our phones we have today, they say once in a while they try to remove your phone from the pouch because of the heat. The pouch can condense inside the battery and can make the phone battery start swelling up. So it's very, very, very necessary. Once in a while you move, let the phone have fresh air. Now, so it's very, very important for that. Now the next thing is what? Acid seal kits for lead acid. For lead acid, use the versus fire suppression for lithium ion. Now, acid spill kits. That means, what does it mean? It means that whereby something they try to say that this is a name for, but we have fire extinguisher, right? Yeah. For offing fire. I'm trying to say for battery, they have their own. You cannot use fire extinguisher off battery. There are some, or you see some people that something battery wants to start catch fire like this and they start pouring water. Don't try to pour water, and they don't do that. They have their own safety. Like I said, their own. They call it the acid spill kit for lead or for fire suppression for lithium. So they have their own different. That's why fire extinguisher is used for things like petrol, not even for high tension. I saw a scenario whereby high tension was catching fire. Now they were all packing water. As they were pouring, the fire keeps going up. And they were pouring the fire. I was supposed to go like ignorant people. They were not supposed to do anything concerning water at all. If the highest thing they could do was sand. The highest thing they could do was to use sand. At least if they don't have anything at all around there, use the sand will easily put down or dry out any put out section. If let's say battery now, somebody asks no, water detergent is for fire. Yes, I'm not saying it's not like that, but it's for fire. I'm telling you, you're not doing anything like petrol, fire disaster. You use things like water and detergent to quickly off the fire. To quickly.
What about fire extinguisher?
Fire extinguisher, yes, but for petrol, yes. If you go to places where they make batteries, you understand, they have their own battery fire suppression. It's not just only fire extinguisher. They have their own particular things. I think somebody should help me search about this fire suppression for us that are doing our own installation. You know, sometimes we might not be with this heat. So at least that sound, that you have to have it before installation. Just keep it in case of any fire. It's a necessity.
But fire extinguisher of various types. You have the class A, class B, class C to F. So
now this one I say now, layman, so people don't understand.
Yes.
So it's very important that even
but all of them are not working for the same.
Installation we did at health center, Kosun.
Okay.
But after the installation, so they call us back like that's catch fire, all this and that. So for fire extinguisher, just like when you say sand, white powder,
yes, fire.
Yes. I'm hearing you know that when you talk about anything battery in this scene, it's what they call it a current, it conduct electricity, and anything liquid conducts electricity. You get it? So anything like that can still can still conduct electricity to even cause more hazard. It's not fire. Let me say it like now. Let me say everybody.
It's not fire. Even the what is it called? The box.
Okay.
Where all these breakers. So when I got there, let me say the called the. So those fire which I saw those that was what you call that like powder.
It was everywhere.
Okay. That one self can
That
also serve
one
because
can
it's
also serve.
electricity in total, not just the battery now.
Government is already entering other hazard. They're already entering causing more fire.
So as I've not put it already.
Okay,
So they have class A. The class A is the ordinary combustion.
Okay.
They use class A meaning on wood, paper, clothes, rubber and plastic.
Which is the normal one you have
Yes.
here, okay?
While for class B is for flammable liquid. They use it for petrol,
Exactly.
diesel, oil,
There's
alcohol.
a difference from the one that is inside car. Continue.
Class C is for flammable gas. They use mostly on all these bitumen, all those propane, all those cooking gas. You have the class D, metal fire. They use mainly on sodium, aluminium, all those stuff. While the class E is for electrical fires.
Exactly. Something I'm talking about
They
now.
use it mostly on electrical equipment, wine and appliances.
Exactly.
While class F,
Not like this. Should look at that one as the one he said that applies.
Which one that the kind of exhibition they use?
Yeah, the hand is like the ball.
Okay.
So there was a guy I follow some people. Then I come across this guy, Jumo Election. Very popular on TikTok. So most of his installation, you do put that in fire extinguisher or just we hang it. Said in case of fire hazard or anything, can quench anything.
Like our future installations, there's the stuff that we're going to be adding. Looks like a breaker. It looks like a bright. It's just a new product that entered into the market. It's also a fire extinguisher.
So what we are trying to say now is say we should do important tip. We should never use water on electrical or oil fire. Always check the label of the fire extinguisher before you use it and stand at the safe distance when aiming the place of the fire. Stand at the safe distance so that you can, if the fire anything can happen, you can quickly run out. So that anything cannot.
Thank you. So we all understand what I'm saying, right?
Yeah.
So there are different types. So you don't just for this kind of actions.
the one we'll be using is going to be like breaker. It's going to be among the breakers. Any small fire inside anything battery.
So for any battery or lithium whatever, then understand that there is at least as engineers we should be inclined. Battery a whole engineer. I'm going carrying type A, not even what I said, type A, without people checking it, and as you know, it did not blow your eyes, you can go outside, your career is gone. People look at you and say, what is he doing? That means this guy is not capable. They're like, he does not know what he's doing. From there now, if it doesn't really engineer, they will say, well, your hand gone, how money is explain. But then you get on top, they say, and these people as you know, say, they explain it. Evidence now, because they are talking about you want to on fire, the thing blow you, say, what's wrong? So at least we are inclined, we are educated in this aspect. And now we are taking notes now. We say batteries are consecrated energy. Short circuiting a battery bank can lead to a explosive result. Ensure clear air gas that are sparks in battery rooms. That means wherever you are putting any battery, make sure that it's well ventilated. Because even you as a human being, you cannot say where there is no ventilation. Hope you understand this part. Let's move to the next part. Environmental and site hazard. Now, this place I'm going to be talking deep on this. Then the other slides I'm just going to be looking at person. This one is where we're going to talk about more. Now, environmental and site hazard. You have the heat stress, hydration, and mandatory site breaks is very important. It's very important. I believe nurse will go deep on that part. It's very important. Even as you are walking, you just calm down, go and drink water, stay hydrated. Now. It's very important to do that. Why? Because when you're on the roof, the heat alone will keep dehydrating you, that you will just need water. You'll be drinking water. You don't drink water because of you're hydrated now. Dehydrated, I mean. You drink water because you want to stay hydrated. Because now, without doing this, it can lead to what whenever your eyes start turning. You start feeling fatigue and all that stuff. I believe she should explain more. Now, we look about the weather. Protocol for lighting, high winds or rain. Now, weather is very important in our work we are doing, which is solar installation. Because now, looking at the lighting aspect, imagine an engineer working on the roof, there's no sky, and there's lighting happening, and it's connecting wire, it's gone. No matter the kind of protection you are wearing, you are gone. So now you need to understand that whenever there's lightning, just leave the work and go. Then you can continue later after maybe the next day, because it's not even good to work even a wet roof. you don't work on a wet roof. You don't work on a wet roof. So during lightning, you know, lightning comes with rain and all that stuff. So you just leave the roof and rest, calm down. The work will not run away. You come to next day. But also on high wind too. High wind is very, very important. You can be working on the roof. This too much now because we did our soon. The winter will be working only in Nigeria. We're also going to other parts of Africa. And we're also seeing that in other parts now there can be high winds. High winds can be happening. You say the wind is blowing too much. People leave the roof, let it not blow you off the roof. Because it's not talking about safety kits. Yeah, we're not talking about Superman suits. You understand me? If you want to fall from the ground now, you want to fall now, you start elevating now, you start flying ahead. But this one now, even your NS and everything, this one. So when you see anything concerning high wind, you calm down and leave it. Now we also already talk about rain. Whether it's wet roof, you leave the roof for the let the rain fall. At least just once you're doing that, I need to talk about it. Once you're doing that, make sure all the wires at the edge are insulated before leaving the roof. That is very important. When leaving the roof, make sure all wires are what. It's very important to it can take life. Okay. The next one, roof integrity. It's very, very important to understand roof integrity. What do I mean? What do I mean by roof integrity?
Check the roof before you have to check the roof after everything. Maybe there's no hole.
Not that one though. If customer invites you, please, I want you to install on this roof. If you climb the roof and look at it, you will, bro, what do you squad up on me? I'm talking. You check it. Is this roof really strong enough?
To work on.
Because you can be walking, you pull leg. I'm saying this because NS2 and what do you call it? Like whatsoever, we're not saving from this. So it's very, very important to understand. Like the roof we worked last time was aluminum roof. The roof was very strong. That even with people without stepping on the stick, even when we step on the normal roof, the thing went in. And let me talk about that one shortly. Now we know that we have when we have the roof now, everybody have the roof now. Inside the roof, the skeleton of the roof. Now this is the skeleton of the roof now. This is the skeleton of the roof. Let me put it this way. This is the skeleton of the roof now. We put this also like this. Now they will not put a aluminum on top or whatsoever roofing sheet they want to use. We know that there's always nail tags, right?
Yeah.
At this place. So if we were to come in as an engineer we are climbing the roof now, we know that we are not supposed to step on places like this. We are not supposed to step on places like this. We know that, right? We know that because stepping on places like this can lead the roof to tear. The roof might be a good material or may not actually be a good material and you are not well, it can tear and lead to your own injury. Now the customer will only tell you what sorry because they have paid you fully. They will only tell you sorry for what is happening to you. You rush into hospital, the money that you are collecting for that job is happening for you.
So you might mentally move.
That's a profession.
Yes, they will tell you to report. They told them you are professional and they are working as a company. So they tell you can't repair the roof. Online expenses on top of online expenses. So when you are climbing any roof, make sure you are stepping on anything, all the wood. You are stepping on the wood, and they will help the roof to remain clean. So when you are done with this one, you say, oh, this roof look neat and still okay. Because most one of the things that keep customers fear as the roof, the roof will get dirty, the roof will get damaged, the roof will start leaking. And now leaking now cannot cause hazard, but now it's for them now. The owner will be like, this roof now if engineers come and install solar, the roof might start leaking. And now but we know that when we are done with installation, we will put some insulating things like the remind me.
Okay.
No, the flashbar. Thank you. We put the flashbar on every place we hit every nail to put the aluminium.
Yeah.
Hope you understand. Now, we said the roof integrity is very well important. Assuming for soft roof spots or structural damage before stepping out or even stepping on, whatsoever, it's very, very important to notice that it's checked very well. And in case of any damage you may have done, on the roof while walking, try to make sure you notice the owner and repair it if it's possible. Let's say a little tear, you repair it or tell the owner to see what happened. They will call a roof repair and put flashback after. It's very, very important because when they start leaking, the integrity of the company can be going down. They say these people don't know work. That's something very, very important for us to note. Hope you understand this slide.
Yeah.
Okay. And next,
is the conclusion and energy response. Oh, I was able to be fast with what I'm talking about, right?
Yes.
So now, conclusion and emergency response. Now we have knowing the location of nearest first aid kit and fire extinguisher is very important. Before you start any work you are doing, make sure you are aware of your surrounding. Okay, I know this is the first aid kit. Okay, this is where we are going to run to if anything happens. Just we do more on that. Now the fire extinguisher to know the kind of fire extinguisher to carry for that particular project you're going for and to use. Now we talk about lastly the emergency contact number and stop work authorities. Now emergency contact numbers are numbers for emergency whereby something happen and hazard have happened because nobody know what can happen. Imagine and hazard happen, you quickly put call for them to come and intervene in what's happening. Sometimes it may not be an hazard. It may be a personal issue. Somebody from roof fell down. What can we do? You have to call a nurse close by. Let there be a standby nurse that is around to help because somebody that can be on the roof. I don't know. No, it's not me. I'm an Igbo man. What's happening? I'm not. No, it happens. You be like, you are to tell you or want to do you on the roof. You be like, no. I'm not for this one now. I said it's too much now. That's me. You be like, before you know, your body does. But you don't be fair. You cannot fall from the roof. Anything that happen, or you maybe let's have to fall now. The hook may hold you. Then they'll now bring you from there and carry you to what the person that will do the treatment. So I'm trying to say this emergency contact is very important. It may not be a number. But there is somebody around, a nurse around that will be able to help. And we're not talking about stop work authority. Now, because of you are working under a company now, and something they did wrong with you, you want to stop work, but the person that you are working under say you must keep working. You have a particular time. I mean, you need to let that stop work authority understand your emergency, understand what's wrong with you. So you need to know the person, and you need to be familiar with the person. And this us, we are like brothers. Anything that is wrong with you, go and sit down. You understand? Go and sit down. No worry, you go and sit down first. Your health is more important than this work. You get the point of what I'm trying to say here. Now we talk about the final Q&A. That is any question you have. Any question you have, I can still go back and come front. I think we still have 10 minutes for yes. We have like 10 minutes. Yes.
Okay.
My
question is.
Okay.
Thank you for the knowledge.
Okay.
Telling us.
Okay.
My question is, this top authority you are talking about, like assuming you are working on somebody's house and such kind of thing, you are not praying for such, but assuming such kind of thing happen.
Yeah.
And that person is still doing what? Forcing you to do what? Finish his work in so time. Why one of you is having injury or something happen, and you guys take that person to the hospital, that person is insisting within that short period that you should do what? Finish it there. What can we do about this authority you are talking about? Is there any
let me explain this design. If anything is wrong with you, health comes first. We will give you in time to either if it's something to rest, we give you time to rest. If it's food that you need to eat at that particular time, you will eat. I believe last time people ate before going to roof. If at least people have eaten before going to roof. Then after then in the roof, anything happen, you come down and walk. So, but now let's not look at this outside meters energy. Let's say you are working somewhere and you start having something an issue. Always try to be familiar. I mean, as for me myself personally, I'm always trying to make sure I'm familiar with the head if I'm working anywhere. So anything that happen, I'll really just make the head understand that this is wrong with me. If they say you must work, bro, my life is more important. I don't like to brothers. If I'm working in a company today and they stress me, I will resign and go and rest. If they ask me, I want to apply on that company, say, why do you resign? I say, I resign to rest. So what do you mean? Say, yes, that's it. If I'm working here and you stress me, I will resign again to rest. Okay, good.
For the case of you said the panel, I believe this was shocking.
Okay.
As a result of when one of the wire is naked and one of the cable you need to connect, you still mistakenly touch the roof, then it starts shocking.
Yeah, okay. Let me just say this. Let me use this roof now as an example. I didn't draw a roof here now. Let me use this roof as an example now. Where we place the panel, we place other here and the rest at the bottom here. Then now let me explain to you why this really happened. After we connected everything, we went down and found out that we were only getting
12 volts. After connecting the whole panel, because we use I think we use parallel, abi.
No, we used series in throughout. We were getting around, we were expecting around, let me say,
I think 600.
no, we were expecting around, yes, around 600 volts.
And
We were seeing only 400.
400.
We
We're not like, what's the problem? We're not like, what's the problem? So we now said, okay, let us go back up to check. Now we cannot go back up again that night because it's already night already. So we now say tomorrow we'll come back. So we now came up, but I just thank God for myself that the other one, the other panels up here. Now these other panels are here now. So now this other one is already down. We already sent it down. Why the other one too? I've sent it here. That come out from me, I've sent it down. So this one now, we open it here. And me now, and I put this one on top here like this to make sure it's alright. So when we came up now, there was no issue. You get now. But now the problem here now when the issue now happened was from here. So now let's work on this. Let's know what's wrong with this. Now bringing out one panel, we now disconnect. We're trying to disconnect. We now find out shock. What's happening? This one wire was like this. And I entered here now. So with these two connected, and this other wire was out like this. Now me, I was at the edge of this roof here. I was still like this, understanding life, trying to hold this wire. And my bro was trying to understand this other wire. This other wire has already loosened up here. And now it's not resting on the roof. And me, I was holding this one, and he was trying to lose this other place. Before I dropped this one, as I dropped this one, I touched the roof, everywhere started shocking. Now, and the shock that was coming from this roof was very, very dangerous. I just think that quickly, it was very close, that I quickly picked it up. And we now quickly get to this other part there. And now head these two on my hand like this and make sure it's done before we now do the connection. Hope you understand why the roof was shocking.
The positive and the negative.
Yes, it was touching that.
They were both naked. Like,
Yes,
both naked.
Yes, both naked on the roof. I know the shock.
So as the shock came, you were driving strength to carry the other.
Oh, what I'm trying to say that our shoe alone was strong, but my buttocks was on the roof. You know the clothes now.
Yes.
On
the roof.
No, on the roof.
We are talking about
400 volts.
On the roof. See, bro, I was sweating on my buttocks like this.
Higher voltage.
See, bro, I think higher voltage do shock. That was when I dealing with higher voltage. Try not to say.
like for what level of the voltage are you focusing
400
on?
volt, bro. And what we are looking at around 600.
So if
And
it's
let me say,
300
if
volts,
mistakenly the 600,
100 volts and above.
mistakenly the 600 was also
From 100 volts, we go shock, but from above,
Even
then
50 volts, you'll be noticing the.
you notice it's bad.
since one of this is the positive and this is the negative.
Yes.
Yeah, these two cable here is now what?
Yes, let me explain. Remember, I said that this one, if I was to connect it, this one will be connected as the positive. Let me mark it here as the positive, as the negative part. Then this other side was the positive part. So if this one connects with this place now, it will now be series. Then this other one now, if it's connected here, they will be together. I hope you understand. So they will now be open here to find out the issue on this roof now. Now doing that, I left this place, which is the positive. I left here, which is the negative. And this one was not touching the roof. That is why the shock happened, which was around 400 volts, which caused the shock. And why the shock really happened, not because we were not wearing the slated shoe or whatever we were on, like, but I was sweating. Because even on the harness, you see sweat. And you know what, we talk about heat, we talk about water, about conduct electricity. And my buttocks was on the roof, which is shocking. And I was shocked at the same time. So I was saying, bro, I shocked. So that is just the reason why the shock happened. Hope you understand that part. Any other question, please? Let me take the last question for you. Any last question? I think I used my time well, and thank you for having me.